Okay, let's start talking about topic 5. So topic 5 is probability theory. So Keller's chapter 6 and Duane's chapter 5. Before we start topic 5, just briefly mention about topic 4, review topic 4. Topic 4 was what? Topic 4 was data collection and sampling. In this topic, I kind of encourage you guys to focus on the definitions. There are several definitions. So please try to remember those definitions in this topic. Collecting data, what kind of method there was, and also the sampling errors and the non-sampling errors. There are some several types of non-sampling errors, which may be your interest to remember. Okay, so that is basically what I want to mention about topic 4. It was a very short topic, so you can briefly kind of list up those definitions and write down those definitions, and then maybe that's gonna be enough for reviewing topic 4. Okay, so let me move on to topic 5. Okay, first, again, in here we are basically starting this probability theory. So this may be your first probability theory course, or even if you took some probability theory course in high school, this may be a little bit more rigorous. Your first little bit more rigorous probability theory course. So that's why we are gonna explain some definitions, introduce some definitions. Then we will try to talk about some method to assign probabilities to events, and joint, marginal, and conditional probabilities, and probability rules entries, and then later we will have Bayes rules. Okay. So first thing that we want to talk about is a random experiment. So basically, probability is a 확률, right? So probability happens because there is some event which is random. Okay, there is some experiment which is random, and then after this random experiment, we have several outcomes, and then some outcome happens with some probability, right? So that's why we talk about this random experiment. So random experiment is what? Random experiment is an observational process whose result cannot be known in advance. So the result is cannot be known in advance. So example is when a customer enters a Genesis dealership, will the customer buy a car, Genesis, or not? That is a 1 0 0 1. 1 if yes, then 1, no, then 0, right? There is a probability, maybe like 20% of probability a customer enters a Genesis dealership, then buy 20% chance they buy car, right? And how much will the customer spend is another kind of experiment. So here, experiment in Korean is a 실험, right? 실험. So experiment. You may think about those kind of experiment in like a lab experiment, right? And bio medical engineering or bio research, there is a lab experiment. Like chemical chemistry course, there is a lab experiment. That is also experiment, but we can think about you draw, there is a population and you draw a person and ask their wage, for example. That is the experiment. You are basically drawing a person and ask a wage of the person. The wage could be different based on which person you pick, right? In that sense, it's an experiment, right? So random experiment can be anything. Basically, it can be anything. There are very wide definition of this random experiment. And the set of all possible outcomes from the experiment, from the random experiment. Actually, there is a further experiment is here, so we don't have to write down this from a random experiment, but the set of all possible outcomes from a particular random experiment is the sample space, and we denote this sample space with S. Okay, S is a sample space. For example, when Citibank makes a customer loan, we might define a sample space with only two outcomes. One is a default, 파산, and no default, 파산하지 않는 것. So default is 파산, bankruptcy is, for example, like default. So no default is a outcome. The sample space describing a Walmart, like a E-Mart in Korea, or 롯데마트. Customers' payment method might have four outcomes. They may pay with cash, they may pay by debit card, credit card, or check. Check is 수표, right? 수표. So that is also sample space. If you draw a die, 주사위, draw a die, then the sample space is 1, 2, 3, 4, 5, 6, which is in the next slide, right? The sample space to describe rolling a die has 6 outcomes. 1, 2, 3, 4, 5, 6. There are 6 faces in this die, and then there are 6 possible outcomes. When we roll 2 dice, 2개의 주사위, then the sample space consists of 36 outcomes, each of which is a pair. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, up to 6, 6. This is S. So S we can write down here is like this. And here this S is 1, 1, 1, 2, 1, 3, up to 6, 6, right? 36 outcomes. So what I want to emphasize here is the outcome. Outcome is here. Outcome is this each kind of possible, thing is basically the outcome. And then S is the sample space, right? Sample space is a set. This outcome is an element, right? Element of a set, 원소, right? Outcome is 원소, and sample space is a 집합, right? Sample space is a 집합 set, right? In terms of class, outcome is a 원소, and sample space is a set, 집합. Outcome is an element, 원소, sample space is a set. Okay, so that is thing that you may want to distinguish. And then why I distinguish this? Because next slide we will define an event. Okay, event. And this event is not outcome. Event is actually a subset, any subset of the sample space. For example, like sample space is like this: 1, 2, 3, 4, 5, 6. If you roll a die, then there are 6 possible outcomes, and their set is sample space. Then outcome is these each guys, right? Each guy of this sample space, the element. Then they are basically outcomes. But the event is, for example, like say A set, which you get less than or equal to 2, then 1 and 2. Then this is an event. Event is what? This event is you get 2 or less, right? Number 2 or less. 2 or less. That is an event. This A, you can maybe think about B is state 3. And this is an event. If you think about this 3 as with this curly bracket as a set, then basically you get number 3, right? And that's an event. And this is actually coincide with the outcome. As an outcome is 3 is an outcome, but 3 is an event. So that's what you need to distinguish. A simple event is this basically. Simple event is this kind of event with only elementary event with a set of only single outcome. So this is a simple event, and this one is a compound event. Compound event consists of 2 or more simple outcomes. No, more simple event, actually, this is true. Simple event. So 2 or more outcomes or 2 or more simple event consist of 2 or more. Let me just say maybe simple 2 or more outcomes. Maybe that's better way of writing down this. Okay. So, and those simple events are all equally likely to occur. So here 1, 2, 3, 4, 5, 6, those simple events. So 1, 2, 6, these events, these simple events, right? These simple events are all equally likely to occur. Then they are basically simple event. But 1, 2, for example, compound event 1, 2, another compound event, say 1, 2, 3, they are not equally likely to occur, right? 확률 이 두 개의 이벤트가 나올 가능성은 다르죠, 그렇죠? Please excuse me, I just repeat this in Korean. So there are 2 different events, and their frequency could be different, right? So, and that frequency will be our probabilities. And there are 3 ways to assign a probability PA, probability A to an event A. First approach is a classical approach. which is based on equally likely events. For example, like A, we have this sample space 1 to up to 6, and then A is 1 and 2. Then classical approach is what? Basically, you can see these two events are equally likely to occur. These 6 events are equally likely to occur, and there are two things. So that means 2 divided by So I shouldn't write down like this. So probability of A is there are 6 equally likely outcomes, and in A there are 2 equally likely outcomes. So we assign probabilities like 2 over 6. That is basically the classical approach. Relative frequency approach, second one is relative frequency approach. Relative frequency approach is what? We have some history. So you draw this die, for example, like 100 times, okay? And then there is a possibility that you got 1, probability that you got 1, probability that you got 2, probability you got 3. So it basically your experiment history or your basically experience will tell what's gonna be the relative frequency, right? And third one is subjective approach. Relative frequency approach was the second one. Subjective approach is the third one. Subjective approach is basically you have some kind of a gut. You have feeling about how likely is the event. For example, like, okay, I'm kind of say I'm an expert about those like, interest rate. Then what's the probability that tomorrow's interest rate is 5%? My subjective probability is 10%. Then, okay, then tomorrow the probability that the interest rate is 5.5% is that probability is 10%. That is subjective probability, subjective approach to assign a probability. Okay, so there are 3 different approaches to assign probabilities to an event. So one thing that I want to mention here is this. Let me delete this, and let me emphasize this. So here, assign a probability to what? To an event. So probability is assigned to an event. Okay, this is important. I will repeat this in Korean. 한국말로 한 번만 강조하기 위해서 얘기하겠습니다. probability는 어디에다가 할당되느냐? 이벤트에 할당된다. Probability is assigned to an event, not to an outcome. outcome에는 assign 되지 않습니다. outcome을 받아들여서 probability 값을 주는 게 아니라 이벤트를 받아서 probability 값을 주는 겁니다. Okay? Please excuse me. This is super important, so that's why I emphasize this in Korean. So in English, same, very important. Probability is assigned to an event, not to an outcome. But if it's a simple event, right? Simple event such as 1 with a set, then this set we assign probability. But this number 1 is a 1. Number 1 we don't assign probabilities. Okay, so better way to write down is probability of an event is a probability of 1 rather than probability of 1. This is maybe wrong, technically sloppy notation. This is more rigorously correct notation. Okay, let's talk about classical approach a little bit more. So if an experiment has n number of possible outcomes, this method would assign a probability of 1 over n to each outcome. So if there are 10 possible outcomes, then 10% to each, probability 0.1 to each outcome. It is necessary to determine the number of possible outcomes. It's very important to determine the number of possible outcomes in each event. That's why we can assign probability. So roll a die, then there are 6 possible outcomes. So each event, simple event, are equally likely with 1 over 6 probability, right? So probability we assign 1 over 6. For example, if we have event which is 1, 2, 3, 4, then there are 4 equally likely outcomes. So probability of A is 4 over 6, which is 2/3. Okay, 2/3. So that is how we assign probability with a classical approach. So another example, we roll 2 dice, and observe the sum, then because we observe the sum, then here the sample space, we have to write down sample space. Sample space, basically, if you write down this table, the first die, this is first die, this is a second die, and these guys are the sums. These guys are the sum. 1 1, then you got 2 1, 2 1, you got 3 3 1, you got 4 4 1, you got 5 6 6, you got 12. Then the possible outcomes, this is basically S. So 2 3 4 up to 12. This is all possible outcomes. So this is a what? Sample space. Sample space. In this sample space, we have possible outcomes, and then what is the probability roll 3, probability that roll 3, probability roll 3, the sum is 3 here and there, right? This event, say A, then A is what? A is roll 3. Roll 3 is basically equal to your rolling 1 2 or 2 1. Okay, there are two possible outcomes, right? Two possible equally likely outcomes. So two equally likely outcomes, right? Two equally likely outcomes. And how many equally likely outcomes? Probability A is, there are 36 equally likely outcomes, and we have 2 equally likely outcomes in A. So the probability is 1 over 18. Right? 1 over 18. Okay, that is how we assign probability by classical approach. Next, relative frequency approach. A computer shop tracks the number of desktop computer systems it sells over a month. So they in 30 days, they basically tracked how many desktop computers they sold for a month. And then there are 1 day they sell basically nothing. Okay, 2 days, so they sold 1 desktop computers. There are 10 days, among those like 30 days, there are 10 days they sold 2 computers. 12 days they sold 3, 5 days they sold 4. Okay, then probability of Y desktops, Y is what? Y is the number of desktops, number. I will use number as this hashtag. Shop, number of desktops sold is Y. So this probability of number of desktops sold is 0 is 1 over 30, because there are 30 days and we observed there are only 1 days that on which we sell only 1 desktops, and there are 2 days they sold 1 desktops. There are 10 days they sold 2 desktops. 12 days they sold 3 desktops. 5 days they sold 4 desktops. So this is how we assign these probabilities: 1/5, 1/15, 1/3, and 2/5, and 1/6. Right. So this is how we assign probability using relative frequency approach. Okay. So this is simple. Relative frequency approach is just based on our experience, right? Experience. Okay, based on our experience or historical observation. Based on experience or historical observation. Third one is subjective approach. In the subjective approach, we define probability as the degree of belief. So degree of beliefs that we hold in the occurrence of an event. So there are a bunch of different events, and we have some belief, subjective belief. So weather forecasting, for example, like probability of precipitation is defined in different ways by different forecasters. 기상청, we always say the 기상청, the weather forecast by the Ministry of Meteorology or whatever, it's always kind of wrong. So because they have, even though they have a lot of data based on their history, based on their judgment, they made some subjective call, and this probability could be always like wrong, right? Because it's a very subjective, right? So and NBC, KBS, SBS, or CNN, they all, or Google, Naver, whatever, will have different, probability about the POP, right? So different, forecasting about raining. So it's basically subjective probability. So 60% means based on the current conditions, amount of the cloud, a lot of things, wind, a lot of things, there is a 60% chance of rain. Okay, then that is basically subjective approach to assign probabilities. Okay, interpreting probability, no matter which method we use to assign probabilities, all those probabilities, or all those probabilities will be interpreted in the relative frequency approach. So it's basically relative frequency. When people say probability, basically the probability is relative frequency. Relative to event B, what is the probability of this event A? That's basically relative frequency. So for example, a government lottery game where 6 numbers out of 49 are picked, the classical approach would predict the probability for any one number being picked is 1 over 49, because there are 49 numbers and 6 numbers are chosen. Then each number is equally likely, so 1 over 49. But when we interpret this, then our interpretation about this 2.04%, or probability 0.0204, this probability is basically relative frequency. In long run, each number will be picked with this relative frequency of 2.04%. That is basically the interpretation of probabilities. Okay. Let's move on to joint probability, marginal probability, and conditional probabilities. Okay. So now we so far we have introduced the event, right? Event. And probability will be assigned to an event. An event is what? Event is a subset of the sample space, right? Sample space. So sample space is S, and this S is basically all possible outcomes of an experiment, right? If you do a random experiment, then there are outcomes, and all those the outcomes, we collect all those outcomes, then that will be the set of all possible outcomes, which is a sample space, and event is a subset. So sample space, if you have learned set theory is what? Set is in Korean 집합. If you have learned set theory, then there is a universal set, right? Universal set, which is a U, and is this 전체 집합, right? 전체. Let me use U is a 전체 집합, right? 전체 집합, universal set, and then there is a subsets, right? The subset A, B, those kind of sets are basically subsets in the basically subsets of the universal set, right? Universal set, and so basically we are gonna assign this probability to this event. So in order to do so, before we do this assigning the probabilities, we want to learn how to combine those events. Okay, how to combine those events. So we will try to do some combinations and those relationship between those events. So that will be those. There are a list of this combinations or relationships. First one is a complement of event. So if A is an event, then A complement is A 여집합, right? A complement, right? And then the intersection of event. If A and B are event, then A intersection B, so, or A cup B, right? So that is also the combination that we can think about. And union of event A union B, or A. This is actually A cap B, right? A intersection B. A cup B is this A union B, and mutually exclusive event, which we will explain later, and then dependent and independent events. So we will talk about these 5 combinations or the relationships. Okay, so this is basically about the set theory, which you may have learned in high school or middle school. So first one is complement of event A. So complement of event A is defined to be the event consisting of all the sample points that are not in A. Okay, not in A. So for example, if you can think about A is a set, A is a set, A is a set, then A complement is basically the set which has X, but X is not in A, right? X is not in A, right? That is basically A complement, right? So complement of A is denoted by A with the superscript C, and the Venn diagram below is illustrate the concept of the complement. So if this is A and this whole universal set is S, the sample space, then A complement is basically all these other part of the sample space which is not A. Okay, and probability, we assign probability here. So probability, we basically, this is super important, we assign probability, right? Assign probability on the set. We assign probability on the one set A, and then we can also assign probability to the A complement. Then A complement's probability, so probability of A complement is 1 minus probability of A. Why? This 1 is what? 1 is actually probability of sample space. So sample space, this whole universal set has probability 1, and there is a probability for this A. Then the other part of this A complement, the universal set, the other part of universal set, this guy's probability must be 1 minus probability A. So we assign the probability. So the important thing is, I mean, of course it's important, but you may have learned the set theory. By set theory, you have learned A complement and A. But what we want to know in this chapter, in this topic, is how to assign probabilities and what is the rule for calculating probability. So if you know probability of A, then probability of A complement is 1 minus probability of A. That is what we want to learn in this, complement of event, right? And let's think about this example. So we roll two dice, right? Then the sample space S is this, right? 1 1 1 2 6 6, and then we define an event A is a tosses, not the coin, the rolling dice and get 7, right? The number 7 as a sum is a 7. Then the outcomes that belongs to this set, this event is 1 6 2 5 3 4 4 3 5 2 and 6 1, right? Having these numbers, we will get the sum is a 7, right? Sum will be the 7. So we get these elements in the set A. And then probability of A is what? Probability of A is we have 6 outcomes, and total among those total 36 outcomes is, so probability is 1 6. Then probability of total is 7 is 1 6, right? 1 6. And probability of total is not equal to 7 here is 1 minus probability of A. So 1 minus 1 6 is 5 over 6. So we can calculate this, right? We can calculate this. So that is basically how we use the events to assign probabilities, right? And next one is intersection of event. So intersection of event, if there are two events A and B, then intersection B is basically two events, intersection of two events. So we denote this event intersection of two events as A intersection B, A cap B, or A and B. So you can say probability of, here actually there is probability of A and B, or you can say probability A intersection B, right? Probability A intersection B. And this probability is called the joint probability of two events A and B. Is basically the probability of the intersection of A and B. Actually, this is not a bold faced, but I think it should be bold faced. I should have make this thing bold. This is important definition. Joint probability of A and B is the probability of the intersection of A and B. Okay, probability of the intersection A and B. So end up this with the Venn diagram. The intersection is this, right? Intersection is this, right? Probability A and B. So this is basically A intersection B, right? Okay. Let's look at this example. Let event A be tosses where first toss is 1. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Event B tosses where the second toss is 5. So 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. Okay. Then the intersection of A and B, right? Intersection between A and B is because the first toss must be 1 and the second toss must be 5. So the only distinct 1, 5 is the A intersection B, right? And the probability, joint probability of A and B is basically this is basically probability of A intersection B, or you can rewrite this as probability A and B, which is there are one equally likely outcome. This is 1, 5, and there are among those like 36 equally likely outcomes. So the probability of A and B is 1 over 36. So this is important, super important. So joint probability of A and B is the probability of the intersection of A and B. It looks very simple, but even when I teach the 수리통계 분석, the mathematical statistics in the graduate level, I teach this kind of thing. So they really need to understand the probabilities assigned to the event. That means probability is a function. It's actually a function which take the event and yield a number that is between 0 and 1. So probability, you can think about probability is a function, right? Function, and this function takes event as an argument, and then it will generate number between 0 and 1. Okay, P is a function that gets an event, and then it will generate number between 0 and 1. So probability is, and in this sense, actually a function, right? And domain is basically all possible event, right? So that's what we have to think about it, right? Anyway, let's move on. The union now. The union of two events. So if there are two events A and B, then the union is A cup B, or A or B. So A cup B or A or B, right? So in this intersection, if there is a A and B here, then event A and B here, then A intersection B is basically all those possible outcome X, which X is in A and X is also in B, right? That is basically A intersection B. Here, A union B or A or B. A union B is X, element X or outcome X, where X is in A or X is in B, or both, right? So union of A and B is denoted as this, A or B or A union B. And the area for the union is basically this, all the green, the area that I'm now highlighting. Okay, so this is basically A union B. In the previous example, in the previous page, tosses where the first toss is 1, and that is event A. And event B is tosses where the second toss is 5. Then this, in A there are 6 outcomes. In B there are also 6 outcomes. Then there are one outcome that is common in both A and B. So in the union of A and B, there are how many outcomes? 12 minus 1, so 11 outcomes in this event, which is the union of A and B. So there are 11 outcomes. So probability of A or B is 11 over 36. So this is probability A union B. Okay, so you can now I want to keep emphasizing this the fact that we are defining the probability about the event. Okay. Next thing, mutually exclusive event, which this concept may be a little bit new to you guys. I think you guys may have learned the intersection, union, and complement. But there is one thing that is called mutually exclusive. Basically, this means the intersection is empty. Intersection is empty set. There is no intersection between A and B. Then we call these two events or two sets are mutually exclusive. So when the two events are mutually exclusive, that means the two events cannot occur at the same time. So basically two events. For example, like you say A is tossing total 7, B is tossing total 11. Then these two events can never happen together at the same time. You roll two dice, you can never get 7 as a sum. At the same time, you can get sum as 11 at the same time. Two events never happen at the same time, right? So these events are mutually exclusive. That means the joint probability is 0. So probability of A intersection B is 0 if A intersection B is the empty set, right? That means what? Probability of empty set is 0, right? You can see probability of empty set is 0. Actually, the thing is probability empty set is 0. So that's why probability of intersection B is 0 if A intersection B is empty. Okay, if A intersection B is empty, then probability of A intersection B is 0. So that means probability A and B is 0, right? Probability of A and B, of course, it should be 0. And that is basically mutually exclusive. We are going to learn independence a little bit later. And this is about the complement, union, intersection, and mutually exclusive event. Okay, so basic relationship of probability. First one, complement of event. So if you have, this is a summary. So A is here, then A complement is the rest of the universal set, right? The rest of the universal set is A complement. If there are two sets A and B, then intersection is the overlapping part, right? So the common element, the set of the common outcome. Let me say outcomes, because outcome here is basically the same as a set of the set of common outcomes. Actually, this is union. This is intersection. So this should go to here. The set of common outcomes. Union is basically let me delete this. So this is intersection, right? Intersection here. Union is basically any outcomes in either in A or in B, right? Any outcomes either in A or B. Mutually exclusive events, basically two events has no intersection. Intersection. No intersection. No outcome in common, then mutually exclusive events. Okay. So now move on to joint probability example. So why there are some mutual fund managers who are more successful than others? So that is basically a question that we want to answer. And one possible factor is where the fund manager earned his or her degree of business administration, right? So MBA, master's degree of business administration, because MBA was once very popular in the US, also in Korea. So if some manager, fund manager on his or her MBA, whether the manager is more successful than the others who don't have an MBA degree. So the following table compares mutual fund performance against the ranking of the school where the fund manager earned their MBA. So some people who got top 20 MBA and some people who don't get top 20 MBA. So we can say this is A. Event A is a fund manager on top 20 MBA degree. Then A complement is what? A person who don't earn top 20 MBA, right? And then there is another event B. Say B is a mutual fund. His or her mutual fund outperforms the market. It's the event A. Then B complement is mutual fund does not outperform the market. Okay, so this is B complement, B and A complement, right? So basically what we are doing here. So whenever you do this kind of exercise question, you face this kind of exercise question, you have to think about how to make this kind of English word or Korean word. If you have faced, whether you can transform this into mass or stat framework. That is basically the step 0 actually. Step 0 we have to do. So you got this kind of question with a lot of English words. Then we have to make sure we have to transform this into math and stat framework. And here basically what we want to do is we want to get the probabilities. So we try to make sure what is the event. So we have to check what is the event, right? So basically this top 20 MBA, a person get top 20 MBA is an event, right? Event. Or you can think about it as an outcome, right? So there may be different outcomes, like somebody get top 1 outcome, top 1 MBA, top 2 MBA, or something like this. Or you can just say top 20 MBA is an outcome. Then you can basically make a simple event, which is a person get top 20 MBA and some person who don't get top 20 MBA. Same, mutual fund outperforms the market, mutual fund does not outperform the market is another outcomes, right? Another event, right? Another event. And event, it's complement, right? And then this 0.11 means what? 0.11 is probability of A intersection B, which is 0.11. So if you randomly pick a mutual fund manager, then probability that the person earned top 20 MBA and the person's mutual fund outperforms the market, that probability is 0.11. This is a joint probability. So joint probability is simply just the probability of the interaction of two sets, two events, right? And this probability is what? This probability is probability of A intersection B complement, right? Probability that a person on the top 20 MBA, but the person, the person on the top 20 MBA and the person's mutual fund does not outperform the market. That probability is 0.29. And this is probability of A complement and B. And this is probability of A complement and B complement. And these guys are joint probabilities. So this thing is basically what? This thing is basically joint probability distribution, which we will learn maybe in the next chapter, joint probability distribution. Why is the distribution? Because you add up those four numbers. If you add up these four numbers, you add up 0.11 plus 0.29 is 0.4, 0.6 plus 0.54 is 0.6. If you add up those four numbers, then you will get 1, right? Then it's basically probability distributions. Okay, this is probability distributions. You can I define this as A and A complement and B complement. You can also use different notation. It doesn't matter. You can say this is A1, this is A2, and A2 is basically complement of A1. And you can define B1 and B2. And B2 is complement of B1 and B1 is complement of B2. That doesn't matter. So next slide shows that kind of way of mathematical framework. So I rather in this slide say A1 is fund manager got top 20 MBA. A2 is non-top 20 MBA. So A1 and A2 are complement with each other. B1 and B2 are complement to each other, right? So we can define this. So this is basically step 0 that I mentioned to you guys. So we basically put this word into mathematical or statistical framework to set the event. Okay, and the table in the previous page become much simpler, right? This is what? This is joint probabilities, right? Joint probabilities. And with these joint probabilities, what we can get is the marginal probabilities. Marginal probabilities. Marginal probabilities what? Basically, these are joint probabilities, right? But for example, this one is probability of A and B is 0.11. Now, marginal probability what? Instead of thinking about two types of event, we only consider one event probability of A. So we want to get probability of A. Probability of A, or this is A1 and B1. We want to get probability of A1. Probability of A1. How to get probability of A1? Think about this. Probability of A1 is what? Go back to previous slide. The probability that a person on top 20 MBA. How to get this? Just think about it. Just don't follow me, robot. Just kind of robot. Just think about it. How to get this top 20 MBA probability? If you think about it, basically how we get the probability that a person on top 20 MBA is just the sum of this 0.11 and 0.29. So 0.4. We have to add up this number and you get 0.4. And this 0.4 is basically top 20 MBA. So if you add up these two numbers, then you will get 0.4. That is a probability of A1, and that is the marginal probability. Marginal means what? In economics, marginal means what? Only a small thing, only one thing. The other thing you basically kind of summing out. So we sum out. So we add across rows or across down columns. We add down columns to get the calculated in the margins of table. So this is part is the margins of table. We get marginal probabilities. Basically, you adding out, summing out the other dimension. So there is one dimension, the other dimension. We basically adding out the other dimension, so that we get probability of A1 by adding up this, so 0.4. Probability A2, we adding up this number, we get 0.6. And this is probability of A1, this is probability of A2, and these are marginal probabilities, right? These are marginal probabilities. And if you adding up across the column like this, then you will get 0.17, and this is probability of B1. And if you adding up the second row, B2 row, then you will get 83, and this is the probability of B2, and they are marginal probabilities. And what does this probability mean? What does this probability mean? What is the probability of the mutual fund managers? Mutual fund does not outperform the market, right? That is 0.83. So 83% of chance the mutual funds does not outperform the market, right? So we write down these numbers in the margin. So that is another reason we call this as marginal probabilities. And then how about this? How about this number? This number, you adding up these numbers, you will get 1. You adding up these numbers, you will also get 1. So all those sum of those probabilities will be 1. If you add these numbers up, then you will get also 1. So this here at the end of the table, you will put 1. Okay, so that is basically the marginal probabilities. If you remember topic 3, then we go back to topic 3. I have mentioned this relative frequency. Actually, topic 2. Let's go. I don't have topic 2 here. So if you go back to here, maybe topic 2 is here. Topic 2, I mentioned this relative frequency table, like cross classification table of frequencies. Here there is these probabilities, right? This probability is a low relative frequency table, but if you write down the cross two-way relative frequency table, actually which will be in the exercise question 3.1, here we will, I think in the classroom we will learn this total two-way relative frequency table. Once we write down the total relative frequencies here, then they will be actually the joint probability. They will be joint probabilities, and that will be joint probability distributions. So that we will learn later in the class. Okay. So anyway, so this is basically the marginal probabilities and joint probabilities and their relationships.